Hi, this is Mr. Barron. What we're going to be doing is learning how to round in chemistry. The way that we round in this class is going to be with something called significant figures. So on your piece of paper, I want you to write down what I write down, because this is going to serve as your notes and your reference for how to round long numbers in this class. So we're calling this LE significant figures. So again, significant figures are used to round. So we have specific rules that we follow for rounding numbers in chemistry, and what we have to be able to do is understand which numbers are actually significant in a measurement. The way we do this is that we set up these rules for counting. So there's actually only 4 rules for counting, and you're not going to find them terribly hard once you look at them. So rule number 1 is that we have to understand that anything that's not a 0 in a number is always going to be counted as a significant figure. We often use the word sig figs, and I'll write this next to the title of the lecture, as shorthand for saying significant figures. So you'll hear me use the word sig figs instead of significant figures. So rule number 1 is that all non-zero numbers are significant. So I'm going to go through a couple of different examples on this. So, examples of numbers using this rule where we're counting significant figures. So if I have a number, say 55, I'm going to count how many significant figures I have. Well, the 5 is not a 0, and the other 5 is not a 0. 1, 2, I make these little tick marks in front of it, and it has 2 sig figs. I'm going to do another example of this. Say I have the number 600. So, the rule says that all non-zeros are significant. So, non-zeros are things obviously not zeros, so the 6 is significant. These 2 zeros are not significant. So we have a total of 1 sig fig. I'll do one last example. Say I have the number 780. I look for all the numbers that aren't zeros, the 7, the 8. These 2 are significant, the 0 is not. I have 2 sig figs. So, that's rule number 1. Rule number 2 is that squish zeros are significant. Now, since squished zeros are significant, the way that we follow these rules is that if I have a non-zero like 6, and then I have a 0, and then I have another 0, and then I have the number 9, so the number 6009, and I want to count significant figures, rule number 1 always applies. So 6 and 9 are automatically significant figures. But see how this 0 and that 0 are in between 2 non-zeros? Because of that, these 2 zeros count as significant. So I have a total of 4 sig figs. I'm going to walk you through one more example of this. Say I have the number 9010. Alright, so for this number, the 9 is significant because of rule 1, the 1 is significant because of rule 1, and this 0 is in between 2 non-zeros, so it's significant as well. This 0, however, is not squished. It's not in between 2 non-zeros. So the number of significant figures for this problem is 3 sig figs. Now, what we're going to do is we're going to look at rule 3. Rule 1 and rule 2 are pretty simple so far. We're going to move to rule 3. Rule 3 says that all zeros to the left of the first non-zero are never significant. Now, that's a lot of words to describe something that's actually pretty simple. Let me walk you through a couple examples. First example. Say I have the number, I'm working with 906, and I want to count sig figs. Well, rule 1 is all non-zeros are significant. Squishers, this is in between two non-zeros, is significant. So it has a total of 3 sig figs. Now, you know that if I added a 0 in front of that 9, that 0 doesn't provide any meaning at all to the number. Because of that, any zeros to the left of that first non-zero, they never count. And I'll provide some examples of this. Some more examples. Say I have the number 0.055. Alright, I know from rule 1 that all non-zeros are significant. I don't have any zeros squished in between two non-zeros, but I do have these zeros to the left of my first non-zero. So again, we have to become comfortable with what a non-zero is. This 5 and that 5 are non-zeros, but this is my first non-zero. That means everything, absolutely everything to the left of it, all of these zeros, they are not significant. And because of that, this number right here has a total of 2 sig figs. All right, we're going to begin with the last rule. Now the last rule is the only tricky one. So far you got it. Let's just review what we've learned so far. So we've learned that anything that's not a 0, duh, is significant. We've also learned that zeros that are squished are significant, and that if I have one hanging off on the end, that's not significant as well. Now, rule 3 says that anything to the left of the first non-zero, they're not significant. That follows our rules quite clearly. Rule 4 provides an exception for when zeros can count when there's a decimal. So I'm going to write rule 4 up here, and this is the most important part. If there is a decimal, and this only works if there's a decimal, zeros to the right of the last non-zero are significant. I'll give you some examples of this. Example number 1. We're going to look at a number that has a total of, let's see here. Let's look at the number 5.080. All right, let's start with rule 1. Rule 1 says all my non-zeros are significant. That makes sense. 0 in between the two non-zeros. That works because it's squished. Squished zeros count. Now, it says in rule 4, if there is a decimal, and there's a decimal, zeros to the right of the last non-zero are significant. The last non-zero is this 8 right here. That means because there's this decimal, anything to the right of it counts. So I have a total of 4 sig figs. Now, let's look at another number. Say I have 5.00. All right, I know the 5 is significant. Hey, there's a decimal. Okay. That means everything to the right of this last non-zero is significant. So these two zeros in this case do count. So there's a total of 3 sig figs. Now, that's different than if I had the number 500. 500 doesn't have any decimal. Because it doesn't have any decimal, the 5 is significant and that's it. And I have a total of 1 sig fig. Now, let's look at one that has all 4 rules playing in at the same time. Let's look at the number 0.006070. Looks pretty big. It's tough to be able to count because you have to actually apply all 4 rules. But if you follow it systematically, it makes sense. So I have 2 non-zeros here and here. Hey, there's a 0 squished. So this 0 is squished. And because it's squished, it does count. Now, rule number 3, let's go back to 3. 3 says that anything to the left of the first non-zero never counts. This is my first non-zero. Because the 6 is my first non-zero, everything to the left of it doesn't count. Now, let's apply rule 4. There's a decimal. That means everything to the right of my last non-zero counts. So the 7 that I've highlighted in pink, That's my last non-zero. Everything to the right of it counts. That means I now have a total of 4 sig figs. Now I'm going to do one last example with you. We're going to do a couple together. You might want to pause the feed and then stop and play around with it yourself. Let's start with 5.06. All right, this question has 2 non-zeros and a squished one. Squished one counts 3 sig figs. Let's do another one. Say I have the number 0.007. Now this is where students make mistakes sometimes. They say, hey, there's a decimal. That means stuff to the right of it counts. No. Stuff to the right of the last non-zero counts, but there's nothing to the right of it. Remember, Rule 3 says all of this stuff to the left of the first non-zero doesn't count, and that's exactly true. So this number right here has only one sig fig. Let's do one last example. 0.0080. Now, in this problem, I said everything to the left of the first non-zero doesn't count, so we ignore it. The 7's significant. There is a decimal, so stuff to the right of that 8 does count, so there are 2 sig figs. Now, we haven't gotten to the rounding piece. The rounding piece on how to round has other rules applied to it as well. But first, what I would like you to do is I'm going to post a worksheet titled Significant Figures. I would like you to practice counting significant figures on this worksheet. When you come back to class, we are definitely going to be doing some practice additionally with counting significant figures, and then we'll take it to the next step on how to round.